Haloform reaction. Myself, Dr. DIGNA VARGHESE. Haloform reaction. The haloform reaction is a chemical reaction where a haloform is produced by the halogenation of a methyl ketone in the presence of a base. What is the general formula of a methyl ketone? RCOCH3 is the general formula of a methyl ketone, where R can be either a hydrogen atom or an alkyl group like methyl, ethyl, propyl, etc., or an aryl group. R is equal to phenyl. Okay, so haloform reaction is a chemical reaction where haloform produced by the halogenation of a methyl ketone in the presence of a base like sodium hydroxide. The reaction can be used to transform acetyl groups, that is COs groups, into carboxyl groups or to produce chloroform, bromoform or iodoform, respective of the haloform halogen used in the reaction. But fluoroform cannot be prepared in this way. That is, CHF3 cannot be prepared by this type of haloform reaction. Now we are going to discuss the haloform reaction in detail. Here you can see a general representation of haloform reaction. A methyl ketone reacts with halogen in the presence of alkali, that is sodium hydroxide, and forming a trihalo compound with sodium halide and water. The halogen represented here by the letter X, and X can be chlorine, bromine or iodine. We know fluoroform is not formed by this reaction. Next step is the trihalo compound reacts with alkali again and form sodium carboxylate and haloform. That is, the general formula of haloform is CHX3. X can be chlorine. If it is chloroform, CHCl3. X may be bromine. If it is bromoform, CHBr3. X may be iodine. If it is iodoform, CHI3. So, in one step, we can write in this way the reaction, that is methyl ketone reacts with 3 molecules of halogen and 4 molecules of alkali to form the sodium carboxylate, haloform, sodium halide and water. Here you can see in this reactions, here 3 halogens, that is here and here 1 sodium hydroxide and here 1 sodium hydroxide. So total is 4 sodium hydroxide and forming sodium carboxylate and haloform. Here we are discussing some examples. We know the general reaction of haloform reaction, that is methyl ketone reacts with halogen in the presence of alkali to give sodium carboxylate and the haloform sodium halide and water. We know the halogen may be chlorine, bromine or iodine and not fluorine, because Fluoroform is not formed by this reaction. So, the first reaction, if the halogen atom is chlorine, what happens? Here, acetone is taken in the presence of alkali and chlorine. It forms sodium acetate and chloroform, sodium chloride and water. Here R is CH3, that is sodium acetate. Here X is chlorine, so it's a chloroform, CHCl3. And sodium halide here formed is sodium chloride and water. So here the sodium acetate is formed with chloroform. Next reaction is if the halogen atom is bromine. Here you can see the acetone reacts with bromine. In the presence of sodium hydroxide, it forms sodium acetate and bromoform. Here you can see its formula CHBr3, that is bromoform. And sodium bromide and water is formed. Next reaction is if the halogen atom is iodine, the same acetone reacts with iodine. In the presence of alkali, it forms sodium acetate and iodoform, that is CHI3, in the also formed with sodium iodide and with water. So these reactions represents different haloform reactions. Haloform reactions are possible in the presence of halogen atom and alkali that reacts with methyl ketone to form corresponding haloform. Haloform reaction may also be regarded as the oxidation of the substrate by the hypohalite formed from halogen and alkali. Here you can see a hypohalite is formed from halogen and alkali, that is, the halogen reacts with an alkali like sodium hydroxide. It forms a sodium hypohalite that you can see here OX. This OX is attached to sodium, so it is a sodium hypohalite and again forms sodium halide with water. So haloform reaction from hypohalite. So hypohalite is formed by the reaction of halogen with alkali forming sodium hypohalite. In next step, the sodium hypohalite reacts with the substrate, that is methyl ketone, and forming a trihalo compound with sodium hydroxide. Here the 3 hydrogen atom replaced with 3 halogen atom and forming a trihalo compound and sodium hydroxide. Okay. So a trihalo compound is formed with sodium hydroxide. In next step, this trihalo compound reacts with sodium hydroxide. Trihalo compound reacts with sodium hydroxide. It forms sodium carboxylate and a haloform. Here you can see the reaction is in such a way that the CH3 with hydrogen forms a compound haloform, that is CH(X3) and RCO attached to this part that forms sodium carboxylate. The net reaction is that here you can see the three halogen atom, that is in this case, and here sodium hydroxide, but here 3 sodium hydroxide. So the net one is 3 sodium hydroxide here and with 1 sodium hydroxide here. So total number of sodium hydroxide is 4 sodium hydroxide, and the trihalo compound, that is RCOCH3 here, and forming sodium carboxylate, haloform, and sodium halide with water. So haloform reaction is also produced or proceeds by the hypohalite formed from the halogen and alkali. Okay. So haloform reaction is answered by any compound of the structure methyl ketone and alcohol. Okay. So not only the methyl ketones but also the compounds like ethanol, propanol, butanol, etc., which can get oxidized when treated with halogen and alkali to aldehydes or ketones containing methyl keto group, that is CH3CO, give the haloform reaction. Here you can see the haloform reaction from alcohol. First, the ethanol molecule reacts with iodine and alkali. It will form or oxidation of alcohol to get aldehyde. Here it is acetaldehyde with sodium iodide and water. In next step, this acetaldehyde reacts with iodine and alkali. It forms sodium formate and iodoform. CHI3 is iodoform plus sodium iodide and water. So from alcohol also we can get haloform. Here gives the mechanism of haloform reaction. The iodine molecule, here ethanol, an alkali is attached to this. The electron is transferred here and the electron is shifted to this position, and this hydrogen is transferred to here and forms I minus HI, then acetaldehyde plus water. Okay, here water is formed. So the byproduct water is also get from by this mechanism and we will get acetaldehyde. This again reacts with 3 iodine molecule and forms 3 hydrogen iodide. These 3 hydrogen molecules are replaced by 3 iodine atoms. Okay, and here the alkali attached to this carbonyl carbon, and this will shifted to this and forming HCOO minus and CHCI3. Okay, here a negative charge Ci, the electron is shifted to this way and it will breaks to form Ci3 minus, here HCOOH. Formic acid is formed. We know again this hydrogen is forming combined with Ci3 minus and forming iodoform here, and here we will get HCOO minus to this sodium ion is attached. So we will get sodium carboxylate, iodoform, then water, and also hydrogen iodide or sodium iodide is formed. Okay. Iodoform test. If iodine and alkali are the reagents used in the haloform reaction, the haloform formed would obviously an iodoform. Any compound of the structure RCOCH3, RCHOSCH3 when treated with iodine and alkali would yield a yellow precipitate of iodoform. Here you can see a secondary alcohol, that is 2-propanol. Here you can see the hydroxyl group is attached to the second carbon atom of the propane. So it is 2-propanol or propan 2-ol. It reacts with iodine and alkali. It will form, that is secondary alcohol is oxidized to give a ketone. Okay. So acetone is formed from 2-propanol and with sodium iodide and water. In second step, this acetone reacts with iodine and for sodium hydroxide. Here you can see a sodium acetate is formed and iodoform also get with sodium iodide and water. Here the 3 hydrogen atom is replaced with 3 iodine, and here the CH3CO part attached to sodium NaO, that is forming sodium acetate. Okay. And iodoform is formed. This iodoform give a yellow color formation, that is iodoform is a yellow precipitate having a characteristic odor. So it is used as a test in qualitative analysis for the presence of a, or to detect the presence of a CH3CO group, that is methyl keto group, or a secondary alcohol group in a molecule. Iodoform test is a test used to identify whether the compound is a secondary alcohol or a compound containing a methyl keto group. Okay, if this type of compound is reacts with iodine and alkali, it will form a low precipitate of iodoform and having a characteristic odor. Thank you for your attention.